Hello, this is Team BrAIN from Northern Virginia, and our team members are Pranav Lat, Krish Jain, Satvik Redratu, Kanush Jain, and Rishi Tavale. Hundreds of thousands of people die of cancer each and every year. Many of these deaths may have been prevented if the tumor was diagnosed earlier, as it would be easier for doctors to fight the tumor in its earlier stages. Our AI solution is the BrAIn Tumor Detector, which is a website that uses AI to diagnose if a person has no tumor, a pituitary tumor, a meningioma tumor, or a glioma tumor, based on an MRI scan. Our AI is able to make an accurate diagnosis 82% of the time. We believe that our AI solution can help fix the issue at hand because an AI can be used in nearly any part of the world for no cost, can process thousands of MRI scans faster than a human doctor, and doesn't suffer from getting tired or hungry, so it will be able to operate at a consistent level of quality. Our inspirations for this BrAIn tumor detector were computer vision applications such as facial recognition and object detection, which are present in things like smartphones and security cameras. Once we saw these applications, we thought, why can't technology like this be used for medical applications, like detecting a brain tumor? When implementing this concept, to make sure that it is ethical, it is important that it can both work at an accuracy similar to that of a doctor and that it doesn't take any shortcuts. What we mean by this is that since most of the time an MRI scan won't have a tumor, a machine learning algorithm could always just pick no tumor and still have a high accuracy. It is important that such an AI application doesn't have problems of this nature. To account for this in our project, we made sure that our dataset had a similar number of MRI scans for each category so that the algorithm couldn't get a high accuracy by only guessing one category. The backend of our project does the classification of the tumor using a machine learning model. Specifically, the model uses a convolutional neural network. Neural networks are mathematical models used for analyzing patterns in data to map an input to an output based on the data. A convolutional neural network is used for images and applies different types of filters to the image. Our backend code uses a dataset from Kaggle with MRI scans labeled as either no tumor, pituitary tumor, meningioma tumor, or glioma tumor. Our dataset is split into a training and testing set. Our project uses the deep learning framework TensorFlow to construct the model. The training set is then passed into the model, and the model is trained to fit the training set. The model is then evaluated based on its accuracy on the testing set. Once we got a model with a high enough accuracy, which for us was 82%, we saved the model so that it could be used in the front end. For the front end of our project, we made a website that is made with HTML and Flask. Our website has a user input the MRI scan from their files, and it then runs the image through the machine learning model. Before it is run through the model, it is first resized into a 100 by 100 pixel image. The website then displays the output of the model.
So here is this is our project demo, and what it does is that you have to upload an MRI scan, and our AI will try to diagnose the type of tumor present in that image. It'll diagnose it as a no tumor, glioma tumor, meningioma tumor, or pituitary tumor. Okay, so let's test it. So we created a friendly user interface to test it. So this is a glioma tumor, and we can test if it works. Just select it and click upload. And we can see that it correctly diagnosed it as a glioma tumor, and it gave our confidence level also, the percentage. And we're just going to do that with each of these images. You can see the name, the type of tumor, and we're going to see if it correctly I diagnosed it as the correct type of tumor. Correctly did that with it. I almost don't want to call it. As you can see, it correctly diagnosed each one of the MRI scans with the right type of tumor. Thank you for watching this project demo.
Now for the Q&A section. Question 1. Why do you split the dataset into a training and testing set? We split the dataset into a training and testing set because the accuracy on the training set is usually higher than the actual accuracy on data outside of the training set. This is because the algorithm fits itself to the training set, and as such, it is possible for it to overfit the training set and fail to get the general trend of the data. To put another way, testing the model on the training set would be the equivalent of evaluating a child's understanding of a topic by using the exact same problems for the test that were on the homework. Is even if the child performs well on the test, it's possible that the child simply memorized the answers from the homework rather than actually understanding the topic. Question 2. Why did you use Python and why did you use Python and TensorFlow? We use Python and TensorFlow because Python has many tools and libraries such as OpenCV and NumPy that make data processing far simpler. The library scikit-learn also helps with finding things like recall, precision, and the F-measure. TensorFlow makes it easy to design the architecture of a neural network, evaluate our model, and test our model. There are, however, other deep learning frameworks that can be used for this, such as PyTorch. The main reason we use TensorFlow is because the people that constructed our backend already had prior experience with TensorFlow. Question 3. What are some other AI solutions in the vein of this one? Projects similar to this one could be used for other bioinformatics purposes, such as detecting if a person has COVID-19 based on an X-ray scan. One of the many benefits of AI applications are their efficiency in terms of time, as an AI can process much more data far quicker than a human. An AI can also be used all throughout the world, whereas a human doctor is restricted to only being able to work in one place at a time. The power of AI's time efficiency is especially important in the medical world, as having an accurate diagnosis sooner can help prevent deaths.